Hello all, welcome to session 44 of the PySpark series. So from this session, we are starting with joins in PySpark. Okay. I have kept this session only for a theory, so we will understand what are joins in PySpark, what are all joins available in PySpark. Okay. And what is kind of a basic definition or basic, I would not say a definition, how we are expecting that join to happen when we are working on the practicals of the joins. Okay, what is join is basically when we want to like join two tables. Okay, in our PySpark case, join two data frames. Okay, um so let's start with joins in PySpark. I don't know. Many people are very much afraid when they hear joins in PySpark. Okay, it is not that difficult. It's the easy thing. Okay, we just need to understand the purposes for which particular join types are used. Okay, fine. Now, um, how many joins we have in PySpark? Okay. Uh, what I remember is first we have inner join, same as SQL, right? Then what we have is left join, okay? Left join. Uh, sorry, okay, left join. The third join is right join, right? Fourth join is full join, okay? Fifth join is, let's say, anti join, right? Sixth join is semi join, right? We will understand everything whatever is available, right? Seventh join is, I think, cross join, right? And then we have one more, which is self join, right? Self join. Fine. So I think these are 8 types of joins we have available in PySpark. Okay. We'll try to understand each one of these one by one. Okay. Now, what inner join will do? Okay, inner join, okay, will join, let's say, each matching record from left data frame to each data frame to each, I would say, matching record from right data frame. Okay, so what it will do, if I have some matching records, okay, based on join column. Okay, so let's say I'm joining some employee data frame, right? Joining employee data frame with, let's say, department data frame. Okay, I have in employee data frame, let's say I have emp id. Okay, let's see, emp id as one column, then employee name as another column. Okay, and let's say department id has another column, right? Employee data set. And I have one more data frame where I have department id and let's say a department name, right? Department department name, right? So here in this case we have department id as the join column, right? It is primary key, if you know. um, I would say this database design basic concepts. It is primary key of this department data frame, and it's foreign key for I would say employee data set or data frame. Okay, so if I have, let's say, department ID 1 present in employee data frame and department ID 1 with department name, let's say HR present, HR department, it will just join department ID 1 from employee data frame to department ID 1 from department data frame, right? That's how it will join each matching record from left data frame to each matching record from right data frame. Okay, it will join only matching records, right? Okay, next left join, what it will do, it will join, uh, it will first put all matching records. Okay, where is that? Okay, so left join, it will join each matching records from left data frame to each matching records on right data frame. Also, on top of it, if there is no match to any of the records from left from left data frame, it will list down all those records padded with null values, okay, for right data frame columns, for right data frame columns. What do I mean by this? For example, I have department ID 2. It is present in employee data frame, okay, but somehow it is not present in department ID, okay. What it will do? It will first do, in case of left join, it will first do inner join, okay. It will match all the, you know, it will join all the matching records, okay, and then it will for non-matching records from left data set department name, it will put it as null, right? That's how left join. So in case of left join, all the records from left data set are present in left join, okay. Wherever there is match, it will work as inner join. Wherever there is no match, it will just pad the right join column as null, right? Very simple. Now left join is this. If you can guess what would be a right join, okay, right join is just, a reverse case of, kind of, we can say, a left join, right? What it will do first, just a second, it will join each matching record, okay, from left data frame to each matching record from right data frame based on join column, okay. Also, if there is no match to any of the records from right data frame, it will list down all those records padded with null values for left data frame columns, okay. Means what I want to say, let's say I have department ID 1 present here, okay, and in department ID column I have department ID 1 and 2, okay. So my department 2 has no employee associated with that, right? So if I do right join, it will list all the columns from right data set. Let's say I'm taking department as right data set, okay. So for department ID 2, it will put employee ID and employee name as null, right? So if there is no match in left data set, it will pad those columns as null, right? That is right join. Okay. Now full outer join. Now full outer join, it is, I would say, a combination of left join and right join. Okay. First, what it will do, it will first do an inner join. Okay. Inner join, as in wherever there are matching records based on join column, it will join those, right? Now I have said it is combination of left join and right join. Now if it has no, let's say left data frame has no matching record in right data frame, okay, it will list down those records padding the right side data frame columns as null, right? And also it will pad wherever from right data frame, if there is no match in left data frame, it will pad all left data frame columns as null. So it is combination of um, left join and right join, okay. Left join is also called as left outer join, okay. I'll just write here left outer join, okay. Right join is called as right outer join, right? And full join is called as full outer join, also called as full outer join, right? Fine. Now next one is anti join, okay. It is also called as left anti join, okay. What it will do, it will it will uh, join all matching records from left data frame to each matching record of right data frame. Okay, now definition looks, sorry, it's reverse. It will join all, or it will it will list down all non-matching records from left data frame. Okay, it will list down all, I would say, records from left data frame which has no match in right data frame. Okay, what I mean to say is, for example, if I have employee ID 1 and 2, if I have department ID 1 and 2 present in my employee column, but in department ID I have only department ID, department ID 1 present. Okay, it will list down a record with only department ID 1, all the records with department ID 1, because department ID 1 has match in department data frame also. Okay, one more thing, it will only list the, and will only return, I would say, return the left data frame columns, left data frame columns as result. Okay, fine. So wherever left data frame has no join, okay, to a right data frame, okay, no match to a right data frame, it will list down all those records. Okay, this is anti join. Semi join, also called as left semi join, reverse of anti join, right? Reverse of anti join, as in, okay, I think the example I told in reverse way. Okay, for example, if I have employee ID, I'll just explain here. Let's say Ganesh, okay, employee ID 1, right? I have employee ID 2, let's say Akshay, okay, having department ID 2, right? Department ID 1 is present here, department name, let's say data engineering, right? So as part of um, left anti join, I'll get this entry as a result, because department ID 2 has no match in right column. Okay, as part of left semi join, I'll get this entry, because semi join will give only matching records from left data frame. Okay, it will list down all the columns from left data frame which has match in right data frame, right? Simple. So it will list down all the records from left data frame which has match in right data frame. It will only return left data frame columns as a result, right? That way. Cross join, it is like, it is I would say Cartesian, right? Cartesian join for all rows from left data frame to all rows in right data frame. Let's not look at definition. I'll tell you what it does. It will basically join each record from left data frame to each record to of right data frame. So what it will do? It will join, this record with this record and this record with this record. It will give all possible results. That is cross join. And self join, it is like joining same data frame with itself. Okay, same data frame. For example, here I have, let's say, manager ID, right? Manager ID. Okay, and let's say 2 is manager of 1, 1 is manager of 2. It is not possible, but let's say they are manager of each other. Okay, so if I want to find the manager name of Ganesh, okay, what I do, I just join. Okay, I just do um, self join on this data frame, so that I'll get the manager name. Okay, I'll do a self join based on employee ID and manager ID, right? So this is basically the basic definitions, okay, of all the joins in PySpark. Inner join, we'll just reiterate, okay. Inner join, what it will do, it will join all the matching records from left data frame to a right data frame, only matching. Left join, what it will do, it will list down all the records from left data frame, okay. Wherever there is match, it will join. Wherever there is no match, it will pad the right data frame columns as null, okay. Right join, what right join will do, it will list down all the records from right data frame. Wherever there is a match, it will join. Wherever there is no match, it will pad left data frame columns as null. We'll see that practically. Just I'm explaining. If you can understand this, if you don't understand, fine, let it be. Full join, full outer join, I said it's combination of left outer join and right outer join, okay. So wherever there is match, okay, left and right has match, it will do that join. Wherever left has no match with right, it will list down all those records, padding right data frame columns as null. Okay. Wherever right has no match with left, it will list down all those records, padding left data frame columns as null. Right. Anti-join, what it will do, it will show all the records, okay, from left data frame which has no match in right data frame, and it will just show all the columns of left data frame. Semi-join, it is reverse of anti-join. It will list down all the records from left data frame which has match in right data frame, okay, and it will list down only left data frame columns as result. Cross join is Cartesian. It's I don't know. It's very definition doesn't seem that simple to me. It is like it. I will just write it very simple. It joins all rows. Okay, from left data frame to all rows from right right. Just to make it simple. Why to do this Cartesian and all these things from right data frame? Okay, irrespective of the match. There is matching or non-matching, doesn't, it will just join each row from left data frame to each row of right data frame, okay, irrespective, irrespective of the match, right. Self join, just joining data, same data frame to itself, okay. So these are the joins available in PySpark. We will understand each and every join, okay, in depth, okay. I'll try to explain in as simple way as possible, right. So this session was dedicated only for theory. I just wanted to let you know what is the basics of each join. From next session, what we will do, we will take one join, okay. For example, next session we will see inner join, okay. So we will see how to join two data frames using one column or multiple columns in PySpark. Okay, fine. That's everything for this session. If you feel this is useful, do like, share, subscribe, and comment. If you have any suggestions, do let me know in comment section, or you can ping me on LinkedIn as well. Fine. That's everything for this session. Thank you so much. I'll see you in next session.